On March 28, 2026, retail investors are keeping their eyes fixed on the familiar glass towers of Palo Alto, but the structural realignment of the world's wealth is moving elsewhere. It is being codified quietly inside a hotel conference room in Whitefield, Bengaluru, during the National Conference on Big Data Analysis. The experts here are working to solve the specific physical problem of data gravity. When datasets reach the exabyte scale, they act like planets, generating a gravitational pull that drags applications, services, and compute workloads into their orbit. For years, the standard practice was to move data to the compute power, usually sitting in an offshore cloud. But trying to move exabytes today triggers massive egress fees, destroys the microsecond latency required for real-time inference, and runs into strict national data sovereignty laws. The physical requirements of technology have flipped. Because we can no longer afford the friction of moving exabytes of data across the world, we are forced to bring massive compute power directly to the data. That shift in digital physics is triggering an intense physical response across India. In the 1990s, the country built its reputation as a back office, providing the software labor that powered Western technology companies. Look at Bengaluru today. The city is rewiring its physical landscape to process its own digital oil locally. We are watching the transition from a passive market that consumes global cloud services into an active, sovereign AI infrastructure hub. Escaping data gravity requires a localized hardware ecosystem designed specifically to keep India's data within its own national borders. The scale of this national hardware deployment is significant. The government is currently coordinating the expansion of its compute capacity to 58,000 GPUs nationwide. Private enterprises are moving just as fast. Companies like Yada Data Services are deploying over 20,000 NVIDIA Blackwell Ultra GPUs to build one of the largest AI superclusters in all of Asia. This creates a symbiotic relationship with hardware giants like NVIDIA. India has become a primary testing ground for their global rollouts, including the Vera Rubin and Blackwell architectures. These architectures require a technical leap. A standard server rack pulls 10 kilowatts. New AI clusters demand 250 kilowatts. That density generates heat that renders traditional air-cooled data centers obsolete. To prevent meltdowns, facilities are rapidly installing hybrid liquid cooling technologies. By pushing power densities this high, Bengaluru functions as a critical co-design testing ground for the hardware itself. Supporting that kind of power draw means physically overhauling the state's power and industrial layout. The Karnataka government is backing this grid with a 1 lakh crore rupee infrastructure plan. They legally classify data centers as essential services, allowing them to operate 24/7 with power tariff exemptions. The city's urban layout is also being restructured. Real estate corridors like Sarjapur are being developed to house both these high-density compute clusters and the incoming elite workforce required to run them. This new heavy physical infrastructure plugs directly into India's existing public digital infrastructure, like the Aadhaar identity system, which generates the population-scale datasets needed to train AI. Bengaluru is physically rewiring its grids and urban corridors to provide the underlying support for this new scale of high-density AI infrastructure. The target state for 2027 is the democratization of AI compute for every developer in India. Through the National AI Mission, the government is subsidizing high-end GPU rentals down to roughly 65 rupees per hour. That price point lowers the financial barrier to entry for local startups. Instead of paying to query Western systems, Indian researchers are using that cheap compute to train their own indigenous, multilingual foundational models, tailored specifically to the linguistic and institutional complexity of their own country. We are seeing a brain gain. Elite tech talent leaving global hubs and repatriating to India specifically to build these sovereign systems. It is an economic pivot. India is moving away from building software for other countries and choosing to own the core intellectual property of the future. When you connect the policy decisions made in Whitefield conference rooms with repatriated engineering talent and liquid-cooled data parks, a larger picture emerges. These interconnected sovereign compute clusters function as a unified national nervous system, and that nervous system is designed to power agentic AI, systems that can autonomously reason, plan, and execute real-world tasks. Backed by national policy, India is producing indigenous foundational models, shifting toward the creation and ownership of its own intellectual property. The global wealth surge projected for 2027 is rooted in concrete action. The roadmap was codified in a Whitefield conference room, and the future is being manufactured today inside the server racks of Bengaluru.